In this video, we're going to actually calculate confidence intervals for a population mean using the graphing calculator. So here's an example problem that will be very similar to question 7, 8, and 9 on your Chapter 5 homework assignment. You randomly select 16 coffee shops and measure the temperature of the coffee sold at each shop. The sample mean temperature is 162 degrees with a sample standard deviation of 10. Find the 95% confidence interval for the population mean temperature. Okay, so the key that we've got going on here, we're definitely using a t-distribution, and the big indicator is sample standard deviation. Okay, we don't know what it is for the population, and therefore we're going to be doing a confidence interval. And in particular, it's going to be what's called a t-interval that uses the t-distribution. Okay. So in our graphing calculator, let me just close that out. All right, let's turn on the graphing calculator. And to get to a confidence interval, we're going to click first the stat button. Okay, and we're going to arrow over twice to the right to where it says tests. And we're going to pick the option that says t interval, which should be number 8. And we'll hit enter. So if you were dealing with actual raw data, we would keep it in the data mode, and we would actually type in the list of data in list L1. But since we're actually dealing with summary statistics already in the problem, which means they actually gave us the sample mean and the sample standard deviation, I'm just going to right arrow over to where it says stats and hit enter. Okay. So X bar represents the sample mean, and in this problem they told us it was 162. Sx in the calculator is the sample standard deviation, which they told us in the problem is 10, so we'll type in 10. And n refers to the sample size. So how many coffee shops did we go to in this case would be 16. So we'll type in 16. And C level is the confidence level, and whatever it says is a percentage, we'll have to change into a decimal. So 95% is 0.95, and that is perfect. We don't have to change that. And then after we do that, we just arrow down so it's blinking on calculate and just hit the enter key. And what you see in brackets up at the top, in parentheses, this 156.67 and 167.33, that's your confidence interval. So basically what we would say is we're 95% confident that the temperature for the average temperature for all coffees is between 156.67 and 167.33, and we're 95% sure of that. So that's how easy a confidence interval is. If we wanted to know what the margin of error is, margin of error refers to how far one of the endpoints, either one, is from the sample mean. Personally, I use the largest endpoint, the maximum value, because then when you do the subtraction, it just leaves you with a positive number. So if I want to know the margin of error, it's 167.33, minus the sample mean, which is 162, which gives us a margin of error of 5.33. And that's all you have to do for the confidence interval problems. So suppose this for the next problem, okay? You randomly select 25 newly constructed homes. The sample mean construction cost is 181,000 and the sample standard deviation is 28,000. And again, we're going to assume the construction costs are normally distributed. What would the confidence interval be if we wanted a 95% confidence interval? Again, it's a t-distribution because we don't know the population standard deviation. We only have a sample standard deviation. So we'll go back, turn the calculator on, of course, hit the stat button, arrow over to test, and go back to t-interval, which was 8. All right, and again, we'll plug in the new new sample mean. So that's x bar 181,000, and the standard deviation they told us is 28,000. And how many homes there were is the sample size, so there's 25. And again, confidence level they told us is 95%, so we can leave it alone and hit calculate. So they're telling us then in parentheses, we're 95% sure that the average construction cost for all homes is somewhere between $169,442 and $192,558. And again, we're 95% sure of that. And then the margin of error would just be the maximum, 192,558, minus the sample mean, 181,000. So we have a margin of error here of $11,558. So maybe you're asking yourself, well, how come we talked about degrees of freedom in the last slide? We didn't do anything with it in the graphing calculator. Well, we didn't do anything with it, but the calculator is basically taking that information about the t-distribution with degrees of freedom. It's basically finding the critical value for you, so you don't have to. You don't have to look at your t-table and plug anything in by hand anymore. The calculator is just going to take those formulas for you and just plug them in. So the only thing you really need to know is when you would use a confidence interval, or in this case, a t-interval, right? When would you use a t-interval? When you're talking about trying to estimate a population mean, which we called mu, and basically we don't know anything about the population standard deviation. Now, what would happen if we were dealing with raw data, like the social networking example? How would we do that in the graphing calculator? Let me switch to that slide and I'll show you in just a second. So here's that social networking example from earlier. And let's just say we want to make a 90% confidence interval to basically estimate the population mean number of friends that people have on Facebook. Okay, so we have the raw data here. We don't have the mean. We don't have the standard deviation for the sample either. Well, that's actually not so bad. The only tedious part will be the typing the data in part, but that won't be too bad, and I guarantee you on the homework you won't have to type in 40 data points for one question. But just hit the stat button, and before you go over to test, just hit enter, and then in column L1 you would just type in all of those, in this case 40 data points. Now I'm not going to do that, I already did that. Once that's all typed in, go back to what you did before. Hit the stat button, arrow to test, go down to t-interval, and now this time we're going to hit the enter key on data. We're dealing with raw data now. Where is that raw data? That's where lists is. It's in column L1, so I don't have to change that, nor do I have to change the frequency. The only thing that changes is the confidence level. So we'll say like 90%. Oops, sorry about that. 0.90. And just hit calculate. And there you go at the top. So we're 90% sure that the average number of friends a person has on Facebook is between 116.78 and 144.82. And you can see underneath it, the X bar, they tell you the sample mean, which is 130.8, and the sample standard deviation of 52.63. So if the homework asks you those questions, what's the sample mean and what's the standard deviation, calculator will do it for you at the same time. So what's the margin of error here? It's just 144.82, the maximum value, minus 116. I'm sorry, the sample mean, which was 130.8. Okay, so we have a margin of error of 14.02. What do you think would happen to the confidence interval if we said a 99% confidence level? Do you think it would get wider, or do you think it would get narrower? Well, let's check. So we'll go back to stat and run that t-interval. Let's change that confidence level to 99% and hit calculate. So actually here our confidence interval now says we're 99% sure that the average is between 108.27 and 153.33. So the confidence interval actually gets larger, okay, as your confidence goes up. And that'll always be the case. Every time you increase your confidence, okay, the interval will always get larger. Okay. And basically, think about it, right? If we go back to what the normal curve looks like, okay, our confidence is always that center point, right? The center of the curve, right? So as you increase your confidence, you're increasing more of that center of your confidence interval, which leaves less room in the tails for error. Okay, so as your confidence level gets bigger, more of the curve is going to get included. Okay, which also reduces your chance of making an error. And that's basically the process of doing confidence intervals for a population mean in the graphing calculator.